here the question is basically that find the two numbers with odd occurrence in an unsorted array. We saw a similar question wherein we had to only find only one occurrence in an unsorted array wherein all the other elements occur even number of times. Okay, and I hope you guys remember we used XOR operation. Fine. But rather here find the two numbers. There are two numbers which occur in odd times. Alright, and all the other numbers are going to have even occurrences. For example, let's suppose 12. Okay, 12 is occurring 1, 2, 3 and 4 times. Alright, fine. So it is even. Then 23, 2 times, even occurrence. Then, so you're left over with 34 and 45, which occurs only one time, that is odd occurrence. Alright, suppose that if you have 45, 45 is occurring 3 times, which is again an odd occurrence instance. Alright, so right now you are supposed to find what? The two numbers which have odd occurrences. Alright, so the first one is using XOR. Alright, we had already studied the one using XOR wherein what is the logic we use? N XOR N is equal to 0. So for every even occurrence, it is N XOR N, it is again going to be 0 only, right? So for every even occurrence on doing XOR, what do you get? You get a value of 0. But for instance, if you do the same XOR for odd number of times, you will be subject to the value of. Alright, so this is something we know already, right? So we are going to use the concept of this initially. Alright, but here what happens is this works totally fine when you have only one number that's going to occur odd number of times. But rather here it's given that there are two numbers that's going to occur odd number of times. Alright, so then how do I proceed further? That is when you have something called set bit concept. Alright, we look at it, but before which we already saw the Bright's algorithm. I hope you guys remember, wherein we found out the number of set bits that's available in a particular integer. That is the second method we went through. Wherein we saw that n and of n minus 1, okay, is used to unset the rightmost set bit. Alright, that is what we saw with this. Okay, but n and negation of n minus 1. Alright, this one will basically help us to find one set bit. Alright, it will help us find one set bit using which we can divide things into two different classes. Alright, we will be using this as a second concept. If you didn't understand, it's totally fine, but just make a note of this. Alright, so this is how we will carry things forward. So initially, we will XOR everything, every element in the array, that is 12 XOR 23, XOR 34, XOR so on until the end of the array. So we will be XORing every other element in the array. So typically what will happen? 12 gets cancelled, this 12 gets cancelled with this 12, similarly 23 gets cancelled off. Why? Because 23 XOR 23 will be what? 0, right? So we'll be left over with 34 XOR 45 as our answer. Alright, fine. Now, second step is to find the set bit. The set bit, as we saw earlier, is going to be this value, right? XOR value and negation of XOR minus 1. Alright, so let's understand the set bit right now. How can I write 12? 12 can be written as, let's have 8, 4, 8, 9, 0, 0. Then we have 34, let's have 16, 32, so 32, 33, 34. Alright, then we have 23, 16, 17, 19, 20, 21, 23. Okay, and then we'll be having 45. 45, shall we? 32, 64, no, 32. 32 plus 8. Alright, so this is going to be 32 plus 8 is 40. Alright, yes, so this is going to be 45. Alright, So 34 XOR 45, what will happen? So when I do this, 1, 0, 0, 0, 1, 0. I am XORing it with what? 45, which is 101, 101. So what will the XOR operation do? The XOR operation is says that same means is going to be 0. Same is 0, different is 1. So we get this value. Fine. So what is this? 8421, which is nothing but 15. Okay. And the set bit is going to be 15 and negation of 14. Alright. So 15 is 1, 1, 1, 1. So 14 is going to be 8421, 8, 9, 10, 11, 12, 13, 14. Okay. So negation of 14 is going to be what? 0, 0, 0, 1. Alright. And what are we going to do? We are going to use the AND operator. So what is happening is that you get 1, 1, 1. So you get 0, 0, 0, 1. Alright. So this. Wait a minute. So we get 0, 0, 0 and then 1. Alright. So the set bit is going to be what? 1. This shall be our set bit. The set bit will basically help us, classify 34 into one class and 45 into another class. Just look at this, okay? 34 is going to have set bit of 0. 45 is going to have a set bit of 1. Okay. So what will happen is that 23 and 45 will come in one class. 12 and 34 will come in another class. So the third step will be to again traverse this entire array. Okay, traverse this entire array, but with every element, right? Every element in the array will get AND with what? This set bit number that you actually found out. Okay, but if this amounts to 2, right? If this along with the set bit number amounts to 2, then it means it's from one class. So we'll do x is equal to XOR array of 5. Else it is from the other class. So basically what you're doing is that you're dividing this entire array into two different components. So 12 and 34 will be part 1. Okay, 23 and 45 will be from another class. So you're basically dividing it into two different classes. So what will happen? 12. So this array will basically check for 12, 23, 12, sorry. 12, 34, 12, 12, 12 again. Okay, this to this will get a check in this if statement. And the else statement, y is equal to y XOR of array of 5. Alright, so in this y statement, right, the second class of 23 and 45 will be considered. So this element, this and this will be considered separately by y. Alright. The other will be considered separately using x. I hope you guys actually got it. Let's write the legible program, alright? So you guys will understand it in a better manner. Alright, so let's have a quick walkthrough of a code that we actually arrived at, okay, with this example. Fine. So here, what is happening is that we are traversing through the entire array, okay, and we find the value of XOR, okay. So we traverse the entire array. So you start with I is equal to 0 until the size of the array that is also given as input in the function already. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so you start from I is equal to 0 for I is 0 up till 1, up till 10. Okay, so less than 10. It's going to run. So it's going to run typically till 9. Okay, so I start with 1. So XOR will be equal to what? Initially the XOR value is given out to be 0. So 0 XOR with array of 0. 5. Fine. Next, the iteration continues. I plus plus. So XOR will be equal to the initial XOR. Okay. XOR with array of 1. So I's value is 0 here. I's value becomes 1 here. So it will become 8. Okay. Next, again iteration continues. When I is equal to 2, XOR will be equal to what? The already existing XOR XOR with array of 2. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Alright. So XOR with 8. So it is going to be 9. So similarly, at I is equal to 9, what will you get? You will get the value of XOR to be 0, 5, XOR 8, 9, 4, 9, 8, 8, 2, 4 and 5. Alright. So what do you know? Any n XOR with n is equal to 0 and any n XOR with 0 is going to be n itself. Alright. So let's rewrite this. So you have 0. XOR 5 is again going to be 0. 5 XOR 0 is going to be what? 5 only. Okay. So this can be written as 5 XOR 8. Fine. So 5 XOR, you have another 5 here. Alright, so this 5 and this 5 can get cancelled. Similarly, this 8 and this 8 can get cancelled. This 9 and this 9 can get cancelled. 4 and 4 can get cancelled using this property. So what am I left out with? I am left out with 8 and 2. Okay, so XOR is going to basically hold 8 XOR 2. So what is 8? 8, 4, 2, 1. So it is 1, 0, 0, 0. 2 is going to be 0, 0, 1, 0. Okay, so if I XOR it, this is going to be same, then it is 0. It's going to be different, it's 1. Different, 1. It's going to be 1, 0, 1, 0. This is going to be my value of XOR, which is 10. Okay, makes sense? So we have completed this step. Alright, so the set bit, the second step is going to set our bits. Why am I setting my bits? In order to divide it into two classes. Alright, so let's understand it right now. XOR is 10. Okay, so what is XOR minus 1? 9. 10 is nothing but 1, 0, 1, 0. What is 9? 9 is 1, 0, 0, 1. So negation of XOR minus 1 is going to be 0, 1, 1, 0. Yes, makes sense. So now I am telling you that leave this off. XOR and negation of XOR minus 1 and operation. So with AND, what will happen? Only if it's 1 and 1 it is true. Every other thing is going to be 0. Okay, and this is going to be my set bit, which will help me classify this into two different classes. So this is going to be my set bit. So now let's analyze. How can 5 be written? 5 can be written as 0, 1, 0, 1. Okay, 8 can be written as 1, 0, 0, 0. And then 9 can be written as 1, 0, 0, 1. Next we have 4, so it can be written as 0, 1, 0, 0. Then we have 2, right? Yeah, I suppose it's wrong. So 0, 0, 1, 0. So what is our set bit? This is 2, second question. 1, 2. This 2 is going to be our set bit. Alright? So just notice now. You can see that it is 0, 0, 0, 0 and 2 is only going to have 1. So it simply means 2 is going to be a separate class. 2 will be one class. Alright. And the other elements are going to be the other class, that is 5, 8, 9 and 4 will be considered separately. Alright, so at the end of the time, what will happen? So when you proceed with this step now, you will understand that you will get the output of 2 here, and suppose that this is y, and in x now what will happen? 5, 8, 9, 4 will be considered. That is, when 5, 8, 9, 4 is considered, it will basically be only one not occurring element, whereas every other element is even occurring. So we will get the output of 8. I hope you understood it. If you didn't understand, there's no issue. We'll look at this walkthrough, okay? So we got that the set bit is 0, 0, 1, 0 and just make a note of this one. Alright? So now, here I am going. Fine. I am traversing from my very first element of 5. Okay? If array of 5 and set bit number. So 5 is nothing but what? 0, 1, 0, 1. And what is my set bit number? 0, 0, 1, 0. So is it set? No. There is 0. Okay, so this condition is false. So I go to the else condition. So what I do is that y is equal to y XOR, what is it? Array of 5. So x and y are initially given a value of 0, okay? So 0 XOR 5. So y is going to hold the value of 5. Alright? So next, I proceed with the iteration. Next, what is going to happen? Array of 1. I pass here. So, when I pass here, 8 is going to be 1, 0, 0, 0. Okay, and the set bit. What is my set bit? 0, 0, 1, 0. What do you get? I don't get anything. I get 0 again. So if condition is false, so I go to the else condition. So again, y is equal to y. You already have a value of 5 here. Okay. So 5 XOR with 8. Alright. So again, iteration continues. So what will happen? I get a value of 9. 9 is 1, 0, 0, 1. Okay. Set bit is 0, 0, 1, 0. So again, what do you get? On AND, doing the AND operation, you get 0 again. So if condition is false, you go to the else part. So y is equal to what? 5 XOR 8 XOR 9. And then you proceed again. You go for I is equal to 4. So when I is equal to 4, what will happen? For 4, it is 8, 4, 2, 1, 0, 1, 0, 0. Again, AND it with the set bit. Set bit is 0, 0, 1, 0. So again, everything is 0. If condition is false, go to else. So else is going to be 5, 8, 9, 4. Alright? Oh my god, it's so tiresome. So how about, I skip everything. I is equal to 4. Alright? So I want you guys to know I is equal to 3. This one is I is equal to 3. And I want you guys to go with 4, 5 and 6. And right now I jump to I is equal to 7. Alright? So at I is equal to 7, what is happening is that I get 0, 0, 1, 0. Value of 2. Alright, set bit. So what is my set bit? 0, 0, 1, 0. See? So it is going to be what? It is going to be some value. It is going to be get a value of 2 and I'm adding it, I get a value of 2. So it passes the if statement. So x is equal to what? X XOR of this 2. Alright, so x is initially having a value of 0, so x is equal to 2. Will be given automatically because it passes the if statement. I mean, like using this if and else, you're dividing it into two separate classes, alright? So 5, 8, 9 and 4 will be in one class and 2 will be in separate class. Alright, but if you take a different combination of numbers, so you will have two different classes such that in each of those two classes, you will have only one number that is occurring odd number of times. Okay, so in each class only one number is going to occur odd number of times. So you will easily be able to arrive at, this one is separate, this one is separate. Okay, this one is going to give the only odd occurrence number in a particular class x, and this one for another class y. So you can easily get x and y. Okay, if you guys do it for a different set of numbers, you will get a different set bit. And using that set bit, you will again separate it into two different classes. And each class is going to contain only one odd occurring number. Okay, I hope you guys understood this. So, with this, it ends our bit manipulation chapter. So, I suggest you that you guys go through a lot of questions. This is just a starter which helps you guys understand, how to look at a question, look forward at a question, okay, how to process things in your mind. This is just a start. So I want you guys to practice more questions so that you familiarize all these concepts, how to use the different kinds of operators, how can questions be possibly asked. Alright, so see you in the next one.